Hello everyone, I am Somesha Janapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. In our previous classes, I have already discussed about bending stress. So today we will learn about bending equation. Here we have two diagrams and here you can see we have taken one cross section and in this cross section here you have PQ beam. Okay. So when we apply some load, there will be bending in this beam. So after bending, the section will look like this. So here you have the beam length, that is PQ, and let's take the total length as L. So for here this diagram is before bending, and here you have the diagram after bending. So first start with the length. Let the length is L. You have PQ length. You can see this PQ length after loading will change into P dash to Q dash. So here if we calculate the strain in this case, so strain will be your change in length to original length. So the original length in previously we have PQ, but after changing we get P dash Q dash. So this P dash Q dash we will have from PQ minus P dash Q dash. We can also write that epsilon equal to 1 minus P dash Q dash divided by PQ. Let we have the equation 1. Okay, we got this first equation. So you can see, let's take it as point O. This to this is your radius of curvature. Let your radius of curvature is R. Also, this distance, the distance of beam from neutral axis is your y. So, the whole O to S is your R minus y, right? Okay. If we put this radius of curvature value and your angle of bending is theta. Let the angle of bending and radius of curvature. Now the equation will be strain is equals to 1 minus this P dash Q dash will be written as R minus Y whole into theta divided by R into theta. Okay, we can cancel this theta with theta. Now we can write R minus R plus Y divided by R is your epsilon strain. Okay, so this R with R will cancel. Now till now we have that strain equals to y by r. This is also one equation. Make it 2. Okay. We know that elastic modulus or Young's modulus is stress upon strain. Right? We can write that E equals to stress upon epsilon. Yes. Also we can write epsilon equals to stress upon E. Yes, we can write it. So, now we can write it like sigma upon E is equals to Y by R. Now we can also write that sigma by Y is equals to E by R. Is there any changes? There is no changes, so we can write it. So here we have the first bending equation, that sigma by Y is equal to E by R. Y is what? The distance from beam to neutral axis. Okay. Next, we will have this equation. Next, here we have one elementary string. This to this is your PQ, and the area of this, let it take as dA. Okay, and the distance is y. So we got already the equation, that is sigma by y equals to E by R. Sigma by y equals to E by R. We can write it sigma equals to E by R into y. Okay. If we calculate force on this elementary string, if we calculate force on the elementary string, so we will have, we know that stress is equals to F upon A, or force by area. So we can write that force is equals to stress into area, right? So here we can write that F equals to E by R into Y into, here we have area as dA. Okay. Now if we calculate moment, we know that moment on any string is equals to force into perpendicular distance. So force is your A and perpendicular distance is nothing but your Y. So we can write it as dm is equals to E by R into Y into, again, the perpendicular distance into dA. Okay. Now your dm will become E by R multiply with Y square into dA. Okay. If we integrate both the sides, let's write it. Integrating both the sides, we will have, we'll continue from this. Integrating both the sides, we will have integration of dm, E by R is your constant, so Y square into dA. We know that second second order of movement is equals to your moment of inertia. So, this we can write that m is equal to E by R into your moment of inertia, that is I. Now we can write m by I is equal to E by R. This is your second bending equation. Bending equation 1 and 2, if we merge it, we will have that m by I is equals to sigma by y is equals to E by R. Here we have the total bending equation. M refers to moment, I will be your moment of inertia, sigma is your stress, y is your perpendicular distance, E is your Young's modulus, and R is your radius of curvature. Okay. So here we have the bending equation. So in this class we have derived the whole bending equation and got m by I equal to sigma by y equal to E by R. In our next classes we will use this formula and will solve lots of numerical on basis of this. Thank you so much.